So let me share my screen and we will look at our video here. So let me move this out of the way. Can y'all see that okay? I don't think this bar ends up on the video, so hopefully there we go. All right, so let me hit fly. I don't know why it's a bomber plane, but anyway. So the plane is flying, and there's this searchlight under it that is following it. So what shape did we end up with that we're going to draw a picture of on our paper? Yeah, right triangle. And we're going to do it with the plane over here. So it's going to look like that because just like in real life, it went the whole way around the earth and came back again. All right, so this is number 5 on your sheet. We've got our right triangle. Now, I do realize that altitudes of planes can change, okay? But in theory, do you understand how the plane would be flying at a constant altitude? It would not be doing this, okay? If you want to have those conversations and about wind speed and all the things, you can travel over to that hallway over there and talk about physics. We're not going to do physics in here. We're going to do math. So like constant altitude with me there. All right, so let me share again. And this is the thing with these videos is I have to keep on sharing my screen to go back and forth between them. How far in the air is the plane? It's 4,000 feet. That is constant. So you can label a constant 4,000 on your picture. The plane is moving. So we need to call that X. Do you see how it was X up there? And it's X of t because respect to time. All right, so that's X. What's the other variable that's going on in this picture? We don't have the hypotenuse. We do not have that information. That is not something we're going to be able to figure out. The angle. And for angles, we use theta. So your theta goes right here. And sometimes, like, if it's a motion problem, is anyone else directionally challenged? East and west is hard for me for some reason. So I'll put like a little arrow on there, like, okay, this is the direction that the plane is flying. So now I need some information from there. So let me go back and read what they told us. We got the altitude 4,000 feet. Flying west 700 feet per second. How would we label that on our picture or on our like list? dx dt. Now hold on 1 second. Let me wait till the plane comes around the earth. Hold on. Just look. It's going to do it in just a second. Hold up. Say there we go. What's happening to that distance? Look, hurry. Shrinking. Okay, so it's not 700. It is negative 700. So dx dt is negative 700 feet per second. We need our question mark value. Sorry, go ahead.
That count as a point?
No, but I recommend doing it because then when you go to plug in all of your stuff, no, the things like on the AP exam that they count as a point is like finding the derivative, getting your answer, putting units on your answer, stuff like that. You don't get a point for just listing things, but you should still do it. I don't know how I would do the problem without listing it out, to be honest. I would be like, what on earth is going on? All right, here's your question mark. How fast is the light pivoting? What is your question mark value? What did you say? I think I just didn't hear you. We didn't have confidence there. It is the angle, but it's how fast is it changing? So it's d theta dt. There we go. I got you to say it. All right, d theta dt is your question mark. And should it be positive or negative? Good, because that angle was shrinking as the plane goes by. Now, you can't talk about all times all at once. This is not everything everywhere all at once. You have to pause at a certain moment. I think I changed this to make it a little easier. Yeah, it says when the plane is 1,000 feet east. That would be when X is 1,000. I'm going to change that because I'm allowed. I'm the teacher and I can do that. I'm going to change it to 3,000 and you'll see why. Okay. So I'm going to change that to 3,000 feet. I'm allowed to do it. So now we're ready to set up a relationship between our variables. And as a heads up, when there is an angle, it's going to be trig. So you need to remember your SOHCAHTOA, your opposites and your hypotenuses and your adjacents and all that stuff. Here's your point of view, which is theta. X is the opposite. 4,000 is adjacent. Is that sine, cosine, or tangent? Opposite. Good job. Tangent of theta. Now, it would be X over 4,000. I'm going to go ahead and make a recommendation that you write it as 1/4,000th X. I just find it goes better like that. No, Miss Cole, I want to write X over 4,000. That's totally fine. Up to you. I'm just saying I found that it goes better that way. Derivative. If you want to write pst on your paper, pst, what's your derivative of tangent? Or if you just remember it. Good job. Secant squared theta And then what goes right here? D theta dt, every variable respect to time. Hey, Miss Cole, I'm scared I'm going to forget to put that. If you made your list of information, you won't forget. It's the thing you're looking for. You'll go back and be like, hey, where does that belong? If you make this list, you're not going to forget. All right. Equals 1/4000th dx dt. Now you're ready to plug stuff in. Secant squared. Well, we're going to come back to that. Do you remember that last time? Okay, well, we'll come back to that. D theta dt is what you're looking for. So now you're like, hey, we're off to a great start. We have like nothing so far. Equals 1/4000th. Now we have dx dt. It is -700. Again, that's why you want to make your list for two reasons. So that when you need that number, you've got it available. It's right here. And also so that you don't forget to put these in the question. Now, this is why I changed the problem. Here, let's see if yellow shows up on here. This is 4,000. That's constant. At the moment that we're talking about, this is 3,000. Without doing any work, what would the hypotenuse be? You guys are awesome. If you were with me in pre-calc, I called those the locker combination ones. Those are your Pythagorean triples. Let's do a little, we'll go off on a tangent here. That is your 3, 4, 5 triangle. It's just with thousands. Does anyone remember any of the other locker combination ones? Close. It's 5, 12, 13. And then the one you're trying to say is 8, 15, 17. And there's one more that there's 4 that I talk about. The other one is 7. Close. That was really good. I'm actually really impressed. You guys were close to all of them. They were in there somewhere. We just found them again. Do you know what I'm saying? Basically, if you know 3, 4, 5, I'm gonna be happy. But it's not bad to have these other ones in your back pocket too, because they save you a whole lot of work. But anyway, that's why I changed the problem. Made it a little easier for us. All right, now we have to do secant. I know you're like, oh my gosh, secant. Which trig function is secant the reciprocal of? Which one? Cosine. Okay, watch me point to this. Cosine is adjacent over hypotenuse. So that means secant is going to be hypotenuse over adjacent. Now I'm not going to write 5,000 over 4,000. I'm just going to write 5 over 4. Ooh, and I actually just realized I did a copy error. I caught it, but I want to see if you did. What did I forget to put in here? It should be 5/4 squared. Good. And then what do you need to do to get d theta dt by itself? Yeah, divide that over. So this would be -700 over 4,000 divided by 5/4 squared, whatever that is. Just verbally, though, what would 5/4 squared be if I made you do that? It'd be 25/16. Good. Now, your units are tricky for this one because they actually aren't in the problem. The time amount is in the problem. That was seconds. This is an angle, though. Your choices for angles are radians and degrees, and there's only one that we do in AP Calc. Radians. Everything is radians. So it's going to be radians per second. An angle will always be radians. And it doesn't say that anywhere in the problem, so that's really tricky.